In this video, I'm going to go over how to use the big X method for factoring a quadratic trinomial. So here we have a quadratic, it has x squared, and it's a trinomial because it has 3 terms. And so standard form for a quadratic is going to be ax squared plus bx plus c. Okay, that's going to be important to remember when we set up big X. So like for this specific example, it is in standard form. We've got x squared first, then x, then the constant. And so we can go ahead and find a, b, and c right now. So starting, a comes from x squared. If there's no number in front of a variable, remember that there's an understood 1 there. So a is 1. B is going to be negative 10. And c is 21. So now I'm going to use these to help me set up big X. So I'm going to start by drawing a big X. And then the way that this works, we do A times C on top and B on the bottom by itself. That's how I always say it to remember, B bottom by itself. In this problem, A is 1, C is 21, so 1 times 21 is 21. And then B is negative 10. Once I have big X filled in, we have to think of 2 numbers that multiply to the number on top of big X and add to the number on the bottom. So what are 2 numbers that multiply to 21 but add to negative 10? Well, if I'm going to multiply to a positive but add to a negative, they have to both be negative values. If I'm multiplying to 21, my options are 1 times 21 or 3 times 7. So I've noticed, okay, well 3 times 7, if I do 3 plus 7, that equals 10. So what about negative 3 and negative 7? That would multiply to positive 21, but add to negative 10. All right, so those are going to help us set up our factored form. I'm going to write the first factor with the negative 3, so we do x minus 3. And then the second factor with the minus 7, so x minus 7. And this is the factored form of the quadratic above. Let's try another one. Now in this one, you might notice that a is not 1. There's a number in front of x squared. So what I want to do first for a problem like this is start by thinking of whether there's a GCF that I could use to simplify the expression. When I look at 2x squared plus 18x plus 28, I notice 2, 18, and 28 are all divisible by 2. So that's what I'm going to use as the GCF to divide out and simplify, because I can divide all of these numbers by 2. So 2 comes out front, and then 2x squared divided by 2 becomes x squared. 18x divided by 2 is 9x. And then 28 divided by 2 is 14. Now, don't forget your GCF in front of the parentheses. We don't want to lose the GCF. We're just using it to simplify our expression so that we can factor a simpler equation, or expression, sorry. All right, so now I'm going to set up big X again. And when I look for A, B, and C, I ignore the GCF. So for this one, now A is 1. B is 9, and C is 14. All right, again, on top of big X is A times C, so 1 times 14 is 14, and B on the bottom by itself. I'm looking for 2 numbers that will multiply to 14 but add to 9. Well, 14, the options are 1 times 14, that doesn't add to 9, or 7 times 2, and 7 plus 2 is 9. So we're going to use 7 and 2. I'm going to write my factored form. Now remember, we had this GCF, so don't forget to bring it down. It's still in front of your factored form. Our first factor is x plus 7, and our second factor is x plus 2. And here's the factored form of the quadratic expression above. Let's try one more. So in this one, again, I have a number in front of x squared. So I'm going to think, is there a greatest common factor, a GCF I can factor out? But 4, 20, and 9 do not share a common factor. There's nothing that divides all 3 of them evenly. So now I'm going to have to move right on to big X. We have A is 4, B is 20, and C is 9. So I'm going to set up big X. It's A times C on top, so 4 times 9 is 36, and it's B on the bottom by itself. All right, two numbers that multiply to 36 but add to 20. Well, 36 actually has a lot more options than some of the other ones we've been doing so far. You could do 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. But in all those pairs I said, only one of them adds to 20, and that's 18 and 2. Now, pause here because there's an extra step. We haven't encountered a problem like this before that has an A value that's not 1. But when you do have an A value that's not 1, you have to then go into your two factor numbers and divide them by A. Okay, this is a crucial step in order to get the correct factored form. Now that I've divided them, I do want to simplify if possible. So 2 over 4, that reduces to 1/2. 18 over 4 reduces to 9 over 2. And now we're going to use these to build our factored form, okay? So I'm going to start by writing it how we typically do it, but there is another additional step. So stick with me. I'm going to write x plus 9 over 2 and x plus 1/2. But this is not correct, okay? There's this additional step. We like to call it bottoms up, okay? Because we don't leave fractions in our factored form. Instead, the bottom, the denominator, goes up and becomes the coefficient of x. So this first factor actually becomes 2x plus 9. And the other one, we're going to do bottoms up. And I get 2x plus 1. Here's my final factored form. So why is that additional step crucial? Well, if you remember with factors, the key is that it still has to multiply back to the expression that we started with. So when I multiply these factors, it should equal 4x squared plus 20x plus 9. Well, in this first factored form that I have in blue, if I were to distribute and multiply these, I would have done x times x, and I would have gotten x squared. Well, that doesn't equal 4x squared. So if you don't remember to first divide by A and then do bottoms up, you won't get the correct factored form. Look at my answer in orange. Let's just check. If I were to do 2x times 2x, I would get 4x squared. Okay, so that's why this step is crucial to get the correct factored form for your quadratic.